For question 4 on our integration by parts, this one has a multi-part integration by parts setup, but also kind of a different thing that's going on it with having to substitute back in something else. So I just want to show you what happens with this one. So in our setup, we're going to set our u and dv first. We are going to always, with our guidelines, set our e to the x dx as our dv, which means my cosine of 2x is my u. Therefore, my du is negative 2 sine 2x, and my v will be e to the x. So I will do my first setup as uv minus the integral of v du, which is times negative 2 sine 2x dx. Oops, forgot my dx here. Which is also not going to integrate. So we will then pull what we need to. I made this e to the x, cosine of 2x plus 2, e to the x, sine 2x dx. Do a second u and dv. Again, my dv would be e to the x dx. My u would be sine of 2x. So du is 2 cosine 2x dx, and my v is still e to the x. So then this initial part stays. I've got my 2 out front, and then I do my uv minus integral of v du. And we're kind of right back where we started, except for that 2. So I have 2 cosine 2x dx. And so you can kind of see this is going to go circular and just keep going and going and going. And there's really nothing you can do to, like, actually use this integration by parts to break it down to the point that you can integrate. And so what we do with those kind of things is we know that this whole thing was originally equal to the original. So I'm going to set this equal to the integral of e to the x cosine of 2x dx, which is almost the same as that if I pull out the 2x. So watch what's going to happen. We're going to treat that integral almost like a variable itself. So now we have e to the x cosine 2x. I'm going to go ahead and distribute my 2 and pull this 2 out at the same time, which is going to be minus 4 integral of e to the x cosine 2x dx. And now I can combine these two and put them together on one side by moving it over. So I'm going to keep e to the x cosine 2x and 2e to the x sine 2x. And I'm going to move that over, which will give me 5 times the integral of e to the x cosine 2x dx. So really, to solve for that integral, all I have to do then is divide by the 5. So I'm going to stick that out front. I never put a plus c on there somewhere, so I will go ahead and put that out as well. And so you've solved now for the integral by using it as a variable itself. So this is your final answer. The integral, oops, not cosine of x to the x, cosine of 2x. The integral of that is equal to all of this over on the left-hand side.